Assalamualaikum and a very good evening to our listener. Kita Muhammad Lahudin di Adnan. We are from the which is particular section 10. We would like to present for our group project report with the pleasure of develop a model for other using character software with the data of A1-B. So my group members, I would like to introduce my name. My name is Abraham bin Azam. And then my group members, other group members is Muhammad bin Samad, Muhammad Bibin, and another one is Ahmad Nabadi bin Abdul Latif. So Ahmad Nabadi will present about the introduction. Okay, let's start.
Bismillahirrahmanirrahim. I will explain about introduction. The hydrologic engineering Tempest River Analysis System is a one-dimensional PC model planned to perform water-driven computation for an organization of open channel. This product will help in performing one-dimensional consistent stream and two-dimensional precarious stream estimation, residue transport or versatile depth calculation, and water temperature or water quality displaying. Other applications of this software are bridge or culvert modeling, inclined structures such as dam, wells, and gate spillway, lateral structure, flood management, sediment transport and management, water quality through temperature, algae, dissolved oxygen, and biochemical oxygen (BOD). The next, I will explain about problem statement. For our group, the data given is located at Sungai Johor. So we choose the place at Kota Tinggi. The problem statement, recently at Kota Tinggi we have a flood. The flood occur when extreme weather combined with other conditions such as improper drainage, water saturated ground, or unusually high tides or wave triggers mass flooding. Flood are most destructive factor impacting the population, social and economic condition. Thus, we are assigned to design an earth drain LA connected to Sungai Johor by following the requirement states. Some modification in order to avoid outflow need to be considered during design. We cannot change the natural causes of the flood, but we can try to control human-made causes. Using Hexcraft software will help us design a proper channel cross-section for the earth drain. So for our objective is to design the drain by following the requirement provided. Second, to analyze the effectiveness of drain. Third, to model the water flowing through system of open channel and compute water surface profile. For literature study, before the Hexcraft program is run, it requires a few information boundaries to interact with pressure-driven method of stream channel, stream, and water development investigation. The cross area is situated in a moderately brief time frame along the stream to describe the stream conveying limit and adjoining flood plain. Hexcraft programming isolates the cross area like this so it can separate pressure-driven boundaries or parameters that are accessible. For instance, the weighted border in the floodway is a lot higher than in the primary channel. In this manner, the stream speed and movement are considered higher in the primary direct than in the floodway. At each cross segment, to portray shape, rise, and relative area. Hexcraft use several parameters such as river station, cross-section number, left and right bank, station location, lateral and elevation coordinate for each terrain point, ridge length between the left floodway rim, center line and right floodway of adjacent cross-section, meaning roughness coefficient, channel contraction and expansion coefficient, geometrical description of any hydraulic structure such as bridge and culvert. For the methodology, I will give to my member.
Alright. Assalamualaikum. My name is Abraham bin Azam. I'm a CA.80069. I will present about methodology. Okay, so in figure 2 here, shows the flowchart for the overall Techras project of our project. It started with the determination of geometric data and followed by inserting the cross-section data for every channel. Then the data for steady flow also has been inserted into the Haskell software. Next, the channel design may need some modification if the water overflow. The result can be generated once there is no error when running the analysis. Steady flow data. The discharge differ in certain channels in three chosen, which is 5 years, 20 years and 50 years. The discharge data is shown in table 1. This table shows that if there is increase in time, the discharge also will increase of every channel. Modification of channel design. When the drainage at an overflow state, the modification factor will be provided to solve the problem. Factor of modification channel are change of cross-section and channel and height of riverbank. Result of modified drainage at each cross-section between channel 0 to channel 1077.5 after the modification of channel are designed. Alright, so next result and discussion, my friend Fitri Ahmad will be present about it. Thank you.
Hello, Assalamualaikum. My name is Muhammad Fitri bin Samad. I will present about result and discussion. Okay, based on the data that have been given to us, we put into the software HackRAS, and it show that first of all, like as we know, the problem that has been presented by Ahmad Rabbani show that our rivers had been flowed recently, so we as an engineer have to develop or to construct a channel that make sure the channel can flow fluently. So there are actually we can do manually and using software, but for this project we have been given a task to test if the software is available or can be used for engineer. And based on the data that we get, show that the result is faster and correct compared to manual calculation. After some modification, the researcher, which is us, managed to solve the problem successfully. Okay, show the next slide. And this is a data that have been given to us, and from this data we put into our software. And as you know, we start from 0 meter until 1077.5 meter, which is quite long. And you can see the channel, the banks, and we takes about 1, 2, 3, 4, 5, 6, 7, 9 cross section across the channel. Okay, next. Okay, this is a data modification drainage after we put the information on the software. We have to modify manually so that the water can flow fluently. And this picture that you see is a channel design modification editor, which is, if you see at the editing tools, there are signs templates show that the templates design, which is we can show what type of design that we want to design for that channel. And you can see the templates is resulting from the template design, which is that we're going to change. Okay, next. This is our you can see figure 3, so show our channel river, and figure 4 show the cross section at the distance 0 meter, but at the location distance 0 meter, water still okay. Next, but when you see at the cross section, at the figure 5, the water is not very fluently because it overflow to the next location. Okay, next. Okay, this is the result from, as you can see, the before is on the left, after is on the right. As you can see, on the left the water is overflow from the channels, and after we do some modification from the right picture, you can see that water is below the ground, and we managed and successfully prevent water from flooding. Okay, next. And this is the same picture as before. Next. Okay, this is the data output from our result by using the head racks. As you can see, okay, so this is the data output from the data that we have been given to us, and we put into the software. As you can see, this is the Q, where in Malay you will call kadar air, and this is the 4.0613. This is data that have been given to us, and the flow area, the top width that have been modified by us. This is the data that you will get after you put the information that the software is needed. So, solution proposed. According to the data given of the drainage alone from that have been given to us by our lecturer is A1-3, which means we a group 3. The water drainage will be overflow at the state as I mentioned before. This is because the level of riverbank is lower than the critical depths. The depth of drainage must be more profound than the current state of the volume of water in the future. 5 years, 20 years, and 50 years will increase. Based on the analysis of the current state, the drainage need to redesign in order to prevent the overflow of water in the future, as I mentioned you before. Okay, solution. Okay, solution proposed. To redesign the drainage, two aspects need to modify. First, the shape of channel, and for this method, the earth drain tend to be an irregular shape. So, the trapezoidal channel will be proposed to solve the problem in order to deepen Sungai Johor. All the channel except channel CH100 will be applied to change the size and shape of the channel. Furthermore, choosing a trapezoidal channel allow changing the area of trapezoidal channel due to the change for suitable measurement of channel depth, bottom width, slide slope, and manning value. Secondly, to modify the height of the riverbank. By increasing the height of the left and the right bank, the tendency of discharge to overflow from Sungai Johor will be lower drastically. As a result of the analysis, after modify the channel with the higher riverbank, the discharge managed to be at an underflow state. Okay, in conclusion, HEADRATS has managed to solve the problem without using manual calculation, which it is for us, it is an essential point that show the beneficial of this software. We just need to put the necessary data which show that this software is essential for engineer, and also, like I said, the software is free, which means any company can use it without the need to purchase and need to buy expensive software. In conclusion, this report has fulfilled the list of requirements from the client, Dr. Muhammad Salahuddin bin Adnan. As a result, the proposed modified drainage alone has been approved successfully using HEADRATS 5.0.7. Finally, HEADRATS software helped a lot, especially to provide modification of solution to redesign the channel. This free software can also deliver the best quality output result and program stability with a user-friendly system. And I say it again, it is free. That's it for us. Thank you from a group 3.